Okay, we're going to continue on with Chapter 9, finish it up here. Choosing the best data display. All right, we've talked about that with different sets of data. It's going to be better to use one type of graph as opposed to another type of graph. It just shows the data better, it's easier to interpret it. So the first thing that I want you to take time to do and put into your notes are these definitions, I guess, and when to use each type of graph. Okay, we have a pictograph, a bar graph, a circle graph, line graph, a histogram, stem and leaf plot, box and whisker plot, a dot plot, and a scatter plot. So I want you to take a minute, pause the video for just a minute, and go ahead and record each type of graph and then what it's mainly used for. Okay, so now that you have that table written down, we're going to look at some examples and how you know when to use each one. And then we're going to look at different types of graphs and explain how they may be misleading, how they're not really the best show of that data. Okay, so these two examples, what we're going to do is we're going to say which graph, which data display would be the best choice to use for it. So example 1, we have the population of the United States divided into age groups. So as I think about this, the first thing I make note of is that the population is being divided into age groups. Okay, so let's say 20s, 30s, 40s, something like that. So if I look back at the table of when to use each type of data, a pictograph shows it using pictures. That's not really going to help what I'm doing. Bar graph shows data in specific categories. That's a possibility. Circle graph shows parts of a whole. That's not going to be ideal. That would be like percentages. Line graph shows how data change over time. Well, we're not looking over a specific time period, so that won't work. A histogram shows frequencies, frequencies of data values in intervals of the same size. So it's a lot like a bar graph, but you're looking at intervals instead of one specific thing. So like if we're talking about age groups, okay, a histogram, one bar would be for ages 20 to 29 and another bar for age 30 to 39. Whereas with a bar graph, one bar would show everybody that's 25 and another bar everybody that's 26 and so on. Okay, so a bar graph is more specific and a histogram shows an interval. So a histogram would be more appropriate in this instance. Okay, so for number 1, for the example, we're going to say a histogram because each bar would be an age group and not just a specific age, an age group like the 20s or the 30s or the 40s and so on. Okay, example number 2, the percents of students in your school who play basketball, football, soccer, or lacrosse. The key thing that I want you to notice here, the key word is the word percents. Anytime you have percentages, you are always going to be looking at making a circle graph because that percent shows a part of a whole. Okay, so you have your table of when to use each type of graph, so that's going to help you out tremendously as you're looking at what's the best data display to use, what's the best type of graph to use. Okay, moving on to the next thing. Identifying an appropriate display. How to pick out which one is going to show the best use of the data. So for this example, it says you record the number of hits for your school's new website for 4 months. So if you're not sure what that means, you're looking at the school's website, and by the number of hits, what they mean is how many times somebody has visited that site. And you're recording this for 5 months. Tell whether the graphs below are an appropriate display of that data. Okay, so the first one, we have the number of hits right here, and then we have the month that it was recorded. So we have a bar graph. Okay, so in August there were a little over 200, September looks like about 300, October maybe 500, November just over 600, and December up around 900. So since we're looking at how many times our school's website has been visited for 5 months, this graph shows us exactly how many were visited in August, September, October, November, December. So yes, this bar graph would be an appropriate representation of that data. Looking at the second graph, we have a histogram, kind of like a bar graph, but we have intervals, not a specific thing down here. So number of hits, okay, in the frequency. Twice there were between 0 and 399 hits. But one thing I'm noticing is this has nothing to do with the months that it was recorded in. Okay, so we're going to say no, this would not be an appropriate data display for the specific type of data that we're looking at. The third one, we have a line graph. Okay, and it specifically shows each month how many times the website was visited, and you can see the growth over time. So yes, this would also be an appropriate data display. Okay, so either bar graph or a line graph are the best way to show this data. All right, moving on. All right, how to know if a graph is misleading or not. Okay, so we have two different graphs here. They're really graphing the same thing. We have box office revenue each year and the total revenue in billions of dollars. So in 2005, $9 billion. 2005, $9 billion. So they show the exact same data. But what I want you to figure out right now is, how are these two graphs different? Because they're clearly different because the lines don't look the same. So I want you to figure out where in the graph there is a difference between the two. Okay, what you probably noticed was that going up the y-axis on this graph on the left, there's a break right here. And this squiggly line means, okay, I'm going to make a big jump. I'm going to go from 0 all the way to 8, and then it goes by ones from there. Whereas the graph on the right, there's no big jump. It consistently, starting at 0, it consistently goes by 2s each time. Okay, so whenever we go to tell which one or which graph is misleading, any kind of break in a graph in an axis like this is going to show that it is misleading. So this graph on the left is misleading because of the break from 0 to 8. Now, break from 0 to 8 is misleading. It doesn't really give you a true picture of what the revenue is doing. All right, on to the next one. Analyzing a misleading display. Okay, so you have this pictograph. It's got pictures. It says a volunteer concludes that the number of cans of food and boxes of food donated were about the same. Is this accurate? And explain. Okay, so it's real easy to see where he got that because the pictures go out to about the same place. However, if you notice the pictures and look at the size of the pictures, there's a lot more cans than there are boxes. And if you look down at the key, each can, it represents 20 cans. Each box represents 20 boxes. Now, if a can and a box were the exact same size, it would be really easy to tell which had more donated. But if you just look at this and count how many cans here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 cans as opposed to only 6 boxes. So even though the pictures come close to about the same place, there are way more cans than there are boxes, and that's just based on the size of the picture. So, was it accurate in saying that the number of cans and the number of boxes donated were the same? And that is no, because the size of the pictures are very different. In order to get a true display, if you're going to use a pictograph, you want your pictures to be the exact same size, so there is no discrepancy in reading the graph. All right, and the last one we're going to look at is looking at why is this misleading. So we have two separate graphs here, example 1, example 2, and we're just going to look at why are they misleading. Okay, and it could be just one reason, it could be multiple reasons. So let's look at the concert ticket prices over here on the left. We have rock band A, B, and C, and then the concert ticket price in dollars, how much the tickets cost. Now, why is this graph misleading? Okay, one thing you should have noticed is right here, there's a break in the axis. It jumps from 0 straight up to 35. The other thing you should also notice is the size of the tickets. If you want a clear picture of the ticket prices, you want the tickets, or really they're kind of serving the same purpose as a bar in a bar graph, but you want them all to be the same size and no break in the y-axis or any axis for that matter. Okay, let's look at the second graph. We have company profits. So number of years, year 1, 2, 3, 4, 5, and then the profit in billions of dollars. So how is this misleading? Okay, the first thing I look for is, are there any breaks in the axis, y-axis or x-axis? And there aren't. Okay, so that's fine there. But what I notice about the actual graph is that notice the bars consistently get wider each time. Okay, so why is it misleading? The bars get wider each time. We need to stay consistent and have our bars be the exact same width as we go through to keep it consistent. Okay, so you'll need to refer back to your Canvas page for your assignment today, picking out which type of graphs are better to use, and then figuring out if a specific graph or data display is misleading and why it's misleading.